Okay, so second video here. What I've got is two screens up. This code actually comes from the Jupyter Notebook, and hopefully it's explained relatively well. But I just wanted to talk through it again on the video to tell you kind of what's going on. If you remember from the last one, what we're talking about is this thing called an activation function. So I'm going to let this thing called Perceptron be our activation function, the Heaviside function. And all you're doing is you're taking your x values. So that's why I turned that into an empty array, and I'm multiplying it by. So I'm doing basically the dot product, right? So you're taking w1 times x1 plus w2 times x2. So that's basically what you're doing in here. Perceptron is equal to np dot. Again, taking the x values, multiplying by all the w values, and then this if statement here basically says, give me a 1 if the perceptron is greater than 0, and else give me a 0. So this code right here is simply executing this idea inside here, right? So it's this idea of the activation function. The next part that I just want to introduce is the training algorithm. So remember what we said earlier about neural nets. The idea of using a neural net is that if you have an error, you have to figure out a way to use that error to, I don't know, to your advantage, if you will, or you have to do something. You have to redo something in your model. Now the question is, well, what is your model? Your model is your weights. That is what it is, or are your weights, I guess. Yeah. So are your weights. If you're able to use that error to make your weights do something different so that it will get it right the next time, then you're kind of moving forward in the right direction. So I'll let you kind of, maybe we'll do this tomorrow in class. We'll talk about the training algorithm and why it's doing what it's doing. It's not that hard if you kind of figure it out. So y minus 0, if there's a delta, if there's a difference between these two, then you're changing delta. If there is no difference between the two, then you're not changing delta. So hopefully that makes a lot of sense to you. But we could or could not. Depends on what you guys want to do in class tomorrow. So let's find out. Let's take this and implement it in Python. So it's the training algorithm. You're putting in x, you're putting in w. You got to put in your y because you don't know. I mean, otherwise you don't know how to train it, right? So I got to know what the target is. Remember we said that earlier. Y was generally the target, and L is going to be your learning rate. And L in this case is taking new's place because I don't have a new in here. So I just used L for learning rate. Okay, so the first thing you do is you calculate what the perceptron is, right? So I got to run X and W into this thing and figure out if it gave me a 0 or a 1. And depending on what happens out of that, well, I'm going to then, so for each one of my weights, I'm going to go through and I'm going to calculate what delta is. So Y minus O for each one of the weights, do this difference, right? So again, they either agree with each other or they don't. They either have a positive 1, a negative 1, or 0, and then multiply it by the learning rate, and then multiply by x of I. So just think about what this little guy right here does. It's pretty important. And then all we're using is this delta thing that we just calculated. We're using that to update the weight. So that will do something for us in order to make it so that we can train a 0-1 neural net with this one. I'm not a neural net, Perceptron Network. Okay, so let's go back over to here. And what I'm going to show you now is with this thing called an AND. And I'm not sure which one we do first in here, but we'll do the AND first. So an AND Boolean table basically is 0, 0 is a 0. So in other words, a false and a false is obviously going to be false if you're ANDing in between those. This is Boolean logic. I'm not sure if I mentioned that or not. But if it's a 0 and a 1, so 1 and 2 or statement A and statement B are both true. I'm sorry, one's false and one's true. Then obviously the AND should be a 0. And a 1, 0 should give you a 0, and a 1, 1 should give you a 1. So the idea here is, can we create something, some kind of perceptron network that'll do that for us? So I mean, here's what we want. I want a 1 to always come into node 0. And again, this is also supposed to keep introducing you to the idea of neural net. In this case, just a perceptron network. But in this case, this is called the bias. So the bias is always 1. It goes in as the 0, and I'm going to take W0 and I'm multiply by the bias. W1 times X1 will give you that second component to it, and W2 times X2. So again, just summing all those. If you're less than 0, report out a 0. If you're greater than 0, greater than or equal to 0, report out a 1. So that activation function comes into effect. What we're looking for is some sort of deal that separates these 3 points, right? Because there's only really there's 4 points on this chart. There's these 3 that represent red. Red represents the 0, and then there's 1 over here that's classified as 1. So let's go to a code here, and it looks like an AND. So this is how you can tell if you did an AND. So it's 1 1. I should probably have the 1 0 0 first. Matter of fact, let's just do that. That doesn't really matter. I just want to line it up with what's in here. So 1 0 0, right? So that represents 1 0 0. This next one is 1 0 1, so it represents 1 0 1. And then 1 1 0 is 1 1 0. And there, you can see the Y's that are associated with there, the targets that are associated with there, with those. And then the 1 1 1 is the only 1. And what we're going to do is we're going to train. So I'm going to let matter of fact, I think I might have to hit shift enter. So let me hit shift enter here, shift enter there, and shift enter there. So what happened is you have to keep hitting shift enter in this thing until you get the same thing before, right? So what you want is what's called convert. You guys know what convergence is, but I want this to converge to something so that if I were to put in the data again, then I would get what we would expect. So let's I don't know, let's let data equal, I think this is in your Jupyter notebook, but just in case it's not, let's just put it in. So 1 1 0, let's see, 1 1 0 1, and then the last one would be 1 1 1. So we expect when I put in this data into the new Perceptron network with these weights that we just printed off, I expect to get a 0, a 0, a 0, and a 1. So that's the idea behind that. And then 4x in data, print x, and then print is it Perceptron x comma w. Happens. So it does exactly what we expect it to do. So we did train our network. If you were to do this before, so let me just do this with the rando thing that I put in here, and let's find out what it does here. Hopefully it doesn't give us the right answer. Oh, so it gave us 1s for all of them. So that didn't make sense until we went to the training. So after you trained it and got convergence, right? So now we have convergence. Now it should give us the right answer. Okay. So you see what's going on there. And again, we could do the same thing with the OR network. So you could get something like this with the OR. I don't know. I mean, if we want to do that one, let's go ahead and do it. Who cares? We got a couple minutes. So in the OR, this one would be 0, this one would be 1, and this one would be 1. And it doesn't really matter. I mean, I guess I could start there, but shift enter, shift enter, shift enter, shift enter, shift enter. All right, it's like we have a convergence. And then when I do this one, we hopefully get the 0, 1, 1, 1. Okay, so notice that we got that guy right there. If I took this, yeah, let's go ahead and do that. I'm going to go just grab the code from the Jupyter notebook and paste it in here, because this will give me kind of what's happening. So if you hit shift enter here and then show result, oh, it doesn't like it. So that's actually what you're getting here, right? So with these model parameters, what I did was I just went over the entire space in between 0 and 1 and the x1 and the 0, 1 and the x2. And you can see that that's going to be a 1, that's going to be a 1, that's going to be a 1, and that's going to be a 0, which is what happened here, right? I had a 1 for 1 0, 0 1 was a 1, and 1 1 was a 1, and the only one that was 0 was that one. So if I were to then go back and train this to be a 0 and a 0, and we do that, and we come back to where we had. So remember, these things are not these are not unique. It could be any line in between this point. So any line that faces kind of that way, that separates this 1, I'm sorry, this 0, that 0, that 0, and this 1, and this looks like it's the AND network, right? So, or the AND perceptron. So again, that's what what that model looks like, and it just basically you can see the separation in between the 0s and 1s. All right, that's all I got for this video. For the next one, I'm going to try to link the H and T that's also in the Jupyter Notebook, and sort of show you. Again, this is the very beginning of neural networks. So just understand that we're not to the real powerful stuff yet. We're simply creating lines in these spaces. And next class, we'll talk about how to create something other than lines. All right, that's all I got, and I will see you next time.